We don't have liftoff. Oh, there we go. Thanks a lot, Paul. That was a very generous introduction, and thanks to the League for inviting me. And Gaston couldn't be here. He's got a 1-year-old, and some of us probably know what that's like. Also, thanks to the selection committee and the new museum. And special thanks to Anne and Nick for sending a lot of emails and coordinating all this business. I haven't been on the Bowery since like 1988, when I was I would have called the golden triangle between CBGB's, the Pyramid Club, and King Tut's Wawa Hut home. And so it's a very different looking place today than it was back then. Anyway, so I'm glad to be here. So first image, I'm calling this talk Fast, Cheap, and In Control, different than the documentary, which would have ended in Out of Control. The reason I put this up is because our practice, just to give a general overview of it, our practice is, let me get this going here. Oops, sorry. Our practice is kind of an alternative to traditional forms of practice. We kind of work outside the architectural sandbox of making buildings and academic research. Instead, we kind of exploit opportunities to build at any scale and where we can exert control over the entire production and design of the project. That will probably change soon. So tonight I'm going to show you several projects where we fabricate everything we design everything that we fabricate. Typically we call this talk Spaces Between the Hammer and the Mouse. Why this image? I think it demonstrates a few things. Frustration with the present industrial technological climate, where conceptualization, that's i.e. design, is valued over execution. And execution is seemingly reduced in importance to the level of rote or mechanical workmanship. Also, the tight integration of concept, computation, and fabrication. We're working in this space. We're not working here, and we're not working there. Also, the tension between the physical and the digital. Instead of being separated into two stages, they're kind of integrated into kind of process of feedback. So it's an approach that's sort of similar to that of the craftsman, where material and conception, making are all working in a process of feedback to yield a built object. This is our studio, which is a 12,000 square foot space in Boyle Heights. It's a design studio and a laboratory for fabrication and a production studio. So this guy's wearing a gas mask, and he's on the computer, and then this kind of open-ended space. We also have parties there occasionally. So it's a very short supply chain between the ideas and the built objects. We do something that I would call the design of production, rather than something called production design, which I used to do in the film industry. Design of the production is really kind of like the design of the factory prior to the design of the car. In this case, Henry Ford's Model A factory. He had to really conceptualize the way that the car was made prior to being able to actually think about the car itself. Feathered Edge. This was at the Museum of Contemporary Art in LA. 2009, I think. It's part of an installation series that was curated by then curator of design and architecture Brooke Hodge on the convergence of computation and craft. And this was the third in a series of works that we call suspensions. The title Feathered Edge refers to a couple of ideas. One, perhaps the softening effect the work had on the rigid architectural setting. So the work acts like a kind of a veil or kind of cloud within the space. And then also the softening of the boundaries between the fields of complex digital computation, mechanization, and in this case printing with traditional handcraft techniques. the technical process that we developed to do this, we call suspensions. It yields something that I like to call gaseous pochés, another one of those 5-minute words. So it was, technically is really an interest in working with a variable unit, the line, the most simple unit that one could make. And in this case, the line manifests itself as a catenary arch because it's made of string. So we're trying to explore the full potential of that in making space. And then we wanted to develop a system of design and fabrication that was integrated, not just a design thing that we could hand off, but something that would produce fabricatable output from the design software. And it really began with a simpler version of the project, a simpler kind of example of this suspension project in a gallery in Chicago called Extension. Extension was this kind of white box. And we found, we can make this kind of three-dimensional aerosol painting and then also kind of control the color through this process of dithering the units across it, and then kind of shape space within and around these implied volumes. That's why we called them suspensions, because we couldn't really come up with a word that would just, this is something that's in between a solid and emptiness, presence and absence. And a kind of clarity from the outside. So it's really based on this. These are studies by Friato, which were used to make structural shells, kind of an analog optimization process. But what we thought when we saw these was, well, perhaps we could just take these and just extend them into space and array them into space in 3 dimensions. And then by virtue of controlling the relationship of all these parts to one another, we could modulate the space. So it's about producing a kind of an effect and delineating space versus optimization for structure. And then another inspiration came from the Four Seasons restaurant by Philip Johnson, and which I'm sure a lot of you are familiar with, and the curtains, which are comprised of catenary chains. And then the color coming from the smoggy skies of LA. So when we first tried it, did analog. And you can do that, no problem. And we could probably do that if we had several years. But we quickly decided that we needed to develop a software system to quickly iterate these things and study the space. So we developed with a software programmer, Ben Dean, a parametric modeling system, which is a kind of a plug-in for FormZ, which exploits the intelligence kind of the material itself and can yield infinite variety of designs. And when we went about outputting the data, cutting it, in this case making this big human machine, cutting it, measuring it, cataloging it, and then stringing it up to latch hook, kind of, the idea is really like a big latch hook rug. This kind of map that sits on the wall, that's attached to the wall, that contains a mapping of where the particular strings go. So this was this kind of digitally aided handcraft. And the effects were quite pleasing. We didn't really know what to call them. This I always love because it's a little bit like a kind of a brush stroke through space, kind of erasing what's behind. So we started calling these suspensions, which is a spatial condition with no inside or outside, no back or front, no clear interior or exterior. Aerosols, gases, gels, blood, milk are all suspensions. Now, once we got to that point, we decided, well, let's, we can make a machine, our own digitally controlled machine, which will output this string, and we could probably even get it to paint the string in discrete locations. The previous incarnation of the project was using solid string. But we thought, well, if we can control exactly where the color is located on the string, we could then create a kind of hovering, kind of spatial thing, an object, if you will, hovering within the ray of catenaries that's comprised entirely of color. So we devised this thing called the Installator 1 with the variable information atomizing module. We designed and manufactured it, especially for the for these installations, and then it precisely saturates the string with solvent-based inks that we work on with a chemist. It has a few different features. One is, of course, the computer, and then this is a spool, and then 4 digitally driven airbrushes that are attached to solenoids. And then a drive wheel, a marker, which holds a big Sharpie, and a pair of industrial scissors. My partner is a genius with fabricating mechanical things. He used to build hot rods. So this was no big deal. So you got the solenoid rigged to a standard airbrush, and so the data from the digital files then triggers all these things in unison. It's like looking at like somebody's fingers while they're playing like an auto harp or something. And there's our man Ron during one of the push periods before we finished an installation for Indianapolis. So this is a very is a digitally controlled machine. It's very, very precise, but at the same time it requires this kind of personal management. You have to have this relationship with the machine in order to make it work. We also added this thing, which is a tensioning device. The biggest problem with this thing when we first started using it was that string stretches, and so this tensioning arm puts even tension on the string and allows it to more or less have the same degree of air, if there is air, in each individual unit. What this yields, I think, is equivalent in some respects to it's kind of like a three-dimensional version of ECOT. ECOT is a resist dyeing technique that's used in Central Asia and throughout all of Asia and parts of South America, where the individual warp yarns are dyed. They're dyed in bundles, put into the loom, and then dyed in bundles, and then reinserted into the loom to yield pattern. So in a sense, what we're doing is like a three-dimensional version of that. And so in our first attempt at feathered edge, we wanted to really make a very clear and representational object hovering within the array of strings. In this case, we're using CMYK inks just as a kind of nod to the history of printing. And in our first attempt, we inserted these big spheres in it. Gave this kind of op art or hard-edged 60s kind of feel to it. But it didn't feel quite right. It wasn't quite enigmatic enough. But this thing, as you can see, it's always been intended to be something that would delineate space, that you would have to walk around, that you would have to explore through movement and with your body and with your eyes. And although it wouldn't keep the rain out, it certainly relates to architecture in the sense that it is in its size and also how it delineates space. So, but we ultimately settled upon an algorithmic approach to inserting color within the strings, which I won't get into, but it yielded very abstract color forms. And then we also, the way we arranged this thing in the space was, you can see there's a rectangular volume there, and this is this skylight space at MoCA, and then a ceiling here. And what we did was we printed big banners or billboard mesh material using a big inkjet printer, and then printed this kind of map on these, and then hung these within the skylight. This is a image of the ceiling panel, and then a drawing of it, which was produced with exactly the same information as was used to generate the cut files. When we went back and looked at what the shape of the color would be, actually after the project was over, and it was something like this. Very, very strange thing. So this, essentially, is Booleaned, or removed from this array of strings. So these are actually the same view of the thing. And then there's a front view. So you can see, some of the magenta. You can see some of the cyan. So this shape would be, in that space. And then another reason we call it feathered edge, because that looks like Farrah Fawcett's hair. Bottom view. And the final thing. It really started to suggest aurora borealis to us. There was to light this. We really wanted to have kind of shafts of light shooting through it, and that lighting needed to be mounted up into this skylight. And the skylight was blacked out, by the way. And so the color began to create a tension with the streaks of light that naturally rained through it. And sometimes it would have clear form, other times it would be very nebulous. So as much as the space was was defined by the string itself, the color also contributed to that. From certain perspectives, you would get these clear streaks, and then as you moved around it, you'll see they would disappear. The strings also interleaved, kind of like this. All of these, the color, the interleaving, the precision of this project wouldn't have been possible had we not done 2 or 3 other iterations in previous projects, which kind of brings me back to the idea of craft. Craft being something that is a kind of tacit knowledge, a kind of unspeakable knowledge, a knowledge of the hand, or knowledge of just how, having done something over and over again, and improving upon it each time. So that really has defined the way that we work. I'm talking about a lot of process-oriented stuff, but which brings me to this slide. That's Frank Zappa. I'm a fan. Gaston's a fan. I imagine some of you are fans. in the early 70s, he was working as both a kind of avant-garde experimental musician, but he was also doing his pop thing. And at the time, the avant-garde was very concerned with the score, making new kinds of scores. Musicians would interpret them, and they would exhibit them in galleries. And it got to the point that they would be exhibited in galleries. And Zappa's eventually decided that this was kind of had gone too far, and he made this kind of famous remark: "You don't eat the recipe." When someone writes a piece of music, what he or she puts on paper is roughly the equivalent of a recipe, in the sense that the recipe is not the food, only instructions for the preparation of the food. Unless you are very weird, you don't eat the recipe. It doesn't become a musical experience in normal terms until the recipe has been converted into wiggling air molecules. And so, you know, on some level, we really relate to this. But because we're not able to, you know, bring these objects here or these spaces here for somebody to experience, we have to kind of develop a narrative around other things besides their direct experience. Cradle for Santa Monica, public art proposal chosen by the Santa Monica Cultural Affairs Division. This is an exploration that I'd call sphere packing, which really is a negotiation between the imprecision of material assembly, material assembled by humans, and material that's been fabricated by humans, and the mathematical ideal within the space of the computer. And we're doing another project in Edmonton, Alberta, that I'm not going to show you, but one is they're both compressive structures, but one is a dome. In Santa Monica, if you've not been there, these are a couple pictures. I'm not going to say more. And this is what we made. The title Cradle comes from, on one hand, the Newton's cradle. I'll tell you what the other hand is later. The structural system is really, you know, you have these cables which are taking up the vertical loads, and then these balls compress against one another and pack to create lateral stability. These things are on the desks of executives in Hollywood movies, if you haven't noticed. I don't think there's real executives have these on their desks, though. This is a kind of scaleless image of it. But when we began doing it, we didn't really quite know how to model this thing. We did take a leap of faith in doing it. This is a kind of digital fantasy version of it. But what we did have this intuition that we could conceptualize very different types of structures with it in different types of forms. And we also were confident that that some of the imagery that it could refer to imagery that might be appropriate for Santa Monica's self-image. So, for example, this is some of the balls, the spheres, and this is the skin of a manta ray, coral, sea foam, fly eye, bacteria culture, and a sweaty bottle of Miller. So, what are the spheres going to be? Well, that was a big question. And I had remembered I'd seen in a gardening store one of these. It was a gazing globe. Popular in the Victorian era, used to attract gnomes. Yeah. Gnomes can't get up on penthouses in New York, can they? So you don't probably have that problem. We have them in our lawns in LA. And what we soon realized was that, we thought, okay, well, somebody's making these things somewhere. They can probably make something to our specifications relatively inexpensively and in large quantities. We eventually found that factory. It was in China, and they do this through hydroforming, which is essentially you making a kind of a primitive welded together using sheet stock material and then inflating it to somewhere in the neighborhood of 10,000 pounds per square inch of water, and then buffing them out till they're mirror polished. And the process of forming them and making the overall shape, we realized was going to be something akin to slip casting. In this case, we've digitally fabricated a buck or a formwork, and then kind of poured the balls like they were giant pieces of concrete aggregate into the formwork. Now, the digital version of this doesn't really work. It works for visualization purposes and basic conceptualization for purposes, but it certainly isn't going to be what's going to work in meat space. So it doesn't account for the effects of this thing. Even with Maya or something that accounts for the effects of gravity, it doesn't really work because it won't account for the variations within the shapes of the balls, which there are. It won't count for variations within the shape of the formwork, which is assembled by people and is made out of materials which have imperfections in them. Anytime you put a single ball in there, if it's slightly off in terms from what you'd have in the digital version, that effect would ripple through the entire system, and you wouldn't have the same thing. So what we decided to throw the digital thing out as a predictive measure entirely and go with this. And it meant that we could construct a very, very inexpensive formwork using relatively unskilled labor and cheap materials. And so we went about studying the distribution of the balls. We made a little model. When we devised a logistics plan, which was to make the balls in the formwork with a big tower, attach the cables to the tower on site, remove this from the tower, drop it onto a big rig, take it to the site, which would have been prepared with a bracket up at the top and a couple of anchorage points there, lift it up with a couple of forklifts, remove the forklifts, and voila. This was built of rock and roll truss, the kind that you see at music festivals and in Madison Square Garden when U2 plays. So here we are putting it up. There's our little digital version of it. Model version of it. And then there's that's your anchorage point. And it's all skinned in Luan, rough around the edges. And then lightly welding them all together. So essentially the structure is like a big sponge. It's soft. It can't exist without the cables. Some people have asked that. Why did you put the cables in then? Because it would fall down. I love this image with all these cables kind of hanging down. I also love the big American flag in the back. It's like people would think we were like Southern rock fans or something. And then we hoisted the thing up with our friend Kelly, who is the chief rigger from the Coachella Festival, so he had no problem doing this and loved doing it. Put it on a big rig, took it to the site, lifted it up to the wall, just like in the pictures. Attached it to a bracket. This is the bracket. This bracket weighs 500 pounds and is this big. 3-inch stainless steel, 316L stainless steel with 350 holes, each one corresponding to the cable, and each one at the angle that the cable intersects the plate, which was all fabricated by a fancy robot. And then we have this method of fine tuning the length of the cables once they're up. And then you pull it off, and it's this really satisfying moment. So it this doesn't aspire to a kind of smooth, automotive kind of aesthetic. It really we came up with a term for this kind of approach, which we call aestheticizing the resolution, or kind of accepting the kind of fidelity that the assembly system will bear. And it's a sculpture on the one hand, but it's also kind of a piece of architecture in that it's quite arresting to walk by this thing. It's quite big. It sticks 12 feet off the wall. And I like to think of them as urban acupuncture. The kind of insertion of these small objects within the urban environment can perhaps catalyze something on a larger scale, which is really what this Maximilian Schell project that Paul was referring to kind of did. Kind of created this buzz and became this moment in LA where people actually went to like something like a pocket park, which doesn't really happen too often if you guys have been there. It's happening more and more, but you're wondering where the shape came from, where the title, on the other hand, about Cradle, that's where it's a lot of those on Santa Monica Beach. Okay, the final one. It's also feminine. There's a feminine reproductive system in there too.